Today's topic is first come first serve CPU scheduling algorithm. So what is CPU scheduling algorithm we have already discussed, and what are the various times related to a process that we have already discussed in previous video. I'll provide you the link of that video in description box. If you want to check out, you can check out that video. Okay, now see, CPU scheduling is basically what? Pick a process from the ready state and give the CPU, allocate the CPU to that process. That kind of thing is known as CPU scheduling algorithm. To which process CPU should be allocated. Okay, now for CPU scheduling there are many types of algorithm. In this video I am going to discuss one, that is first come first serve. So this is the simplest CPU scheduling algorithm. Okay, what is the funda in this algorithm? Say in this case, it assigns the CPU to the process which comes first. As the name suggests, first come first serve. जो प्रोसेस पहले आएगी CPU उसी को पहले मिलेगा. Okay, पहले आएगी means the process which comes in ready state first. Okay, in ready state, that process would be allocated to CPU. Fine. So that is the simple funda of this algorithm, and the mode of this algorithm is non-preemptive. Now what does that non-preemptive means? See, two types of CPU scheduling algorithms are there. One is preemptive and one is non-preemptive. Now what does preemptive means? If a process is running in the CPU, then that process can be forcefully removed from the CPU, and CPU can be allocated to some another process. That is known as preemptive CPU scheduling algorithm, or you can say preemption. And what is it? This non-preemptive scheduling algorithm. In this case, once a process has been allocated to, once a CPU has been allocated to one process, means the one process is running right now, then that process cannot be removed from the, from CPU, okay, until its termination. Only thing is, if the process voluntarily wants to exit from the CPU, means it has been terminated, it has finished its execution, then it can terminate from the CPU. This topic is first come first serve CPU scheduling algorithm. Okay, now what is CPU scheduling? What is CPU scheduling? We have already discussed in previous video, and as well as the various time related to a process that we have already discussed. If you want to check out that video, I'll provide you the link in description box. You can check it out. Okay. So basically CPU scheduling is what? Just picking a process from the ready queue and give the CPU to that process, or you can say allocate that CPU to that process. That is known as scheduling. To which process CPU is to be allocated. Okay, that is CPU scheduling. Now many types of CPU scheduling algorithms are there. So today I am going to discuss with you first come first serve CPU scheduling algorithm. So the simple funda of this algorithm is it assigns the CPU to the process which comes first. As the name suggests, first come first serve. The process which comes first in the ready queue, that process, the CPU is to be assigned to that process first of all. Okay, that is the funda, and it is one of the simplest CPU scheduling algorithm, plus it is non-preemptive CPU scheduling algorithm. Now what does this non-preemptive means? See, two types of CPU scheduling algorithms are there. One is preemptive and one is non-preemptive. So in non-preemptive, see, if a CPU has been assigned to one particular process, then that process hold the CPU until its termination, or you can say until it reaches to a waiting state or blocked state. You cannot forcefully, or the operating system cannot forcefully remove that process from CPU. Okay, but in preemptive scheduling algorithm, the process which is running in the CPU right now, that process can be removed forcefully from the CPU. Okay, and then CPU can be allocated to some other process, maybe based on some time quantum or priority or something like this. Okay, we will discuss this in detail later. Now this is non-preemptive CPU scheduling algorithm. Once a process has been assigned to CPU, you cannot forcefully remove that process from CPU. But see, that process can itself exit from the CPU when it terminates, or when that process wants to do some IO operation, then that process itself can exit from that CPU, can leave that CPU. Okay, but we cannot, the operating system cannot forcefully remove that process from CPU. Okay, now let us take this example. With the help of this example, we are going to discuss first come first serve scheduling. We have 5 processes. Arrival time of every process is given, and this one is the burst time of every process, or you can say it is the CPU time. Now this burst time is what? That particular process needs how many unit of time to complete its execution. Okay, that is maybe 2 unit. And arrival time is means what? At the time, it is the time at which the process arrives in ready queue. Okay, now see why this scheduling would be required. If in ready queue we don't have any process, then obviously we cannot schedule. CPU would be idle at that time. And if only one process is there, suppose P1 is there, only one process has been arrived in ready queue, then the decision is what? Only we can assign the CPU to this P1. But problem would be there at the same time when we have more than one process in ready queue. At that time, to which process CPU is to be allocated. Okay, and that decision will be taken care by this algorithm on the basis of this rule. जो पहले आएगी ready queue में, the CPU would be allocated to that process. Okay. Now check out, to solve this kind of numericals on CPU scheduling, first of all you have to draw Gantt chart. If you are able to draw this chart properly, then you can say that almost 90% work has been done. Okay, now we are taking the time like this, 0 to something like this. We are not taking the exact time like at 10:30 or at 11 or 11 o'clock or something like this. Okay, this is the relative time. Okay, now you have to draw a Gantt chart, and we will start the working of the CPU from time 0. Assumption is that would be started from 0. Fine. Now you have to check at 0th time, is there any process that has been arrived in the ready queue? Yes, we have one process, because arrival time of P2 is 0. Then no doubt, is there any other process? No one. Then no doubt CPU would be allocated to P2. And for how long CPU is to be allocated to this P2? Check out the burst time or the CPU time, that is only 1 unit. So for 1 unit, CPU would be allocated to this P2. See here the assumption is no process would be required any IO operation to perform, any IO device. Okay, only the requirement is CPU. Fine. Now P2 has done with its execution. Now P2 terminates. Okay, the state of P2 is now it has been terminated. Now check out at 1, now time is 1, is there any other process which has been arrived? Arrival time of this is 2, 2, 3 and this has been done 4. So at time 1 we don't have any process in ready queue, then we cannot schedule any process. Then see next process will come at 2. So till 1 to 2 CPU would be idle because we don't have any process. So now check out at 2, which process is there? One is P1 and one is P3. 2 processes has been arrived. But the rule is it assigns the CPU the process which comes first. Now you have to check out kaun si process pehle aayi hai, but we cannot say anything because the arrival time of both the processes are 2 and 2, same. Then if arrival time is same, this condition arises, then you have to check out, you will go with the order of writing of these processes. कैसे इनको लिखा गया है? See, P1 has been written before P3. So we will take P1 first. So P1 would be allocated to the CPU. And for how long time? P1 requires only 2 units of time for its completion. Fine. So here the time would be 4, because at 2 P1 has been assigned to CPU. It take 2 units of time, then 2 plus 2 is 4. Now P1 has been terminated. Now at 4, see at 4 in ready queue, how many processes are there? P4 has been arrived, because at 3 P4 has been arrived, P5 has been arrived at 4. So in ready queue we have P3, we have P4 and P5. Now CPU would be allocated to which process which has come first. Now out of these three, the arrival time of which one is less, that is this one, 2. So this would be allocated to P3, and P3 would take 3 unit of time for its completion. Then here you will write 4 plus 3, that is 7. Now P3 has been terminated. Fine. Now we have only two processes, P4 and P5. Check out the arrival time. This one is less than 4. So P4 would be there for how long time? For 5 unit of time. So 7 plus 5 is 12. Now at last remaining is P5. Now here is 12 plus burst time of this one is 4, that is 16. So this is the Gantt chart for this, you can say for these processes. Okay. Now see this FC first come first serve algorithm use which data structure? Queue data structure, okay, for its execution. Now sometimes they ask you the waiting time of these processes, or you can say turnaround time, or average waiting time, average turnaround time, response time. Fine, such type of questions can be asked. So in this video we will discuss everything. Now first of all we will find out the completion time. If you don't want to find out, then it's okay, you don't have to write this one. Without this you can also solve this numerical. I will tell you how. See, what is the completion time? At the time at which the process has been completed, has gone to the terminated state. Now for P1, at what time P1 has been terminated? Check out P1 has been terminated at time 4. Fine. So 4 is the completion time of P1. For P2 it's 1. For P3 it's 7 completion time. For P4 has been terminated at 12, and P5 at 16. Okay. Now next stage you have to find out turnaround time. Now what is turnaround time? We have already discussed in the last video. See, this time is this one was arrival time when the process comes into ready queue, then it go to running state, and then it go to the terminated state. So here we have completion time. So this time from the arrival time to its completion, this total time is known as turnaround time. So you can say completion time minus arrival time, that is known as turnaround time. Or in other word, if you want to say, then turnaround time would be waiting time plus burst time, because after arrival and before completion, here the process at some time process was waiting, and at some time it was executing, its burst time. So it is combination of both, waiting time plus burst time. Fine. Okay. Now check out the turnaround time. Completion time minus arrival time. Completion time for this is 4, arrival time is 2. So turnaround time would be 2. This one is 1 minus 0, 1. 7 minus 2, that is 5. 12 minus 3, 9. 16 minus 4, that is 12. So this is the turnaround time. Okay. Now check out the waiting time. How waiting time can be calculated? Through this, waiting time would be turnaround time minus burst time, that would be waiting time of that process. Fine, because turnaround time is combination of both the times, waiting as well as burst time. So if from the total of this one, if you remove the burst time, then remaining is what? Waiting time of that process. Now waiting time would be turnaround time minus burst time. Turnaround time is 2. See, burst time is 2. 2 minus 2, 0. 1 minus 1, 0. 5 minus 3, 2. 9 minus 5, 4. 12 minus 4, that is 8. So this is the waiting time. Now sometimes they can ask response time. Now how response time is to be calculated? The time at which the CPU has been allocated to a particular process first time. See, first time. Okay, that is response time after the arrival of that process. Means a process has been arrived, that process is in ready queue, and the time when the process is to be, then CPU is to be located to that process first time. Fine. One thing is when as well as the process arrives, CPU is to be allocated to that process at the same time, then maybe response time is what? 0 only. And maybe sometimes the process has to wait in the ready queue for some time, and after that CPU is to be allocated to that process. Okay, so check out the response time is what? Check out for P1, at what time CPU is to be allocated to P1? At time 2. First time at time 2. And when P2 has been arrived, the arrival time of P2 is 2. So it means as whenever this process comes in the ready queue, at that time only CPU has been allocated to that process. Means 2 minus 2, that is 0 only. So response time is 0. Now check out for P2. At what time CPU has been allocated to this P2 first time, pehli baar? At time 0. 0, and arrival time of P2 is 0. So response time is 0 minus that is 0 only. For P3, see, for first time at time 4 CPU has been allocated to this P3 at time 4, and the arrival time of P3 is 2. So P3 was in waiting state for 2 seconds. 4 minus 2, that is 2. Okay. And now for P4, say 7, at 7 P4 CPU has been allocated to P4 first time, and P4 has come at time 3. So 7 minus 3, that is 4. For P5 it will be 12 minus 4, that is 8. And in another term you can say, in non-preemptive scheduling algorithm, waiting time and response time would be same, always same. But that is the case when scheduling algorithm is non-preemptive. Here you can see waiting time and this one is response time, both are same. Okay. Now sometimes they can ask you what is average waiting time. So how I guess everybody know how to calculate average waiting time and average turnaround time. You can do what? Total of this turnaround time and divided by 5. Total of this waiting time and divided by the number of processes. Number of processes are 1, 2, 3, 4, 5. So divided by 5. So this is how you will get average turnaround time and average waiting time. So this would be, so average waiting time would be 5.8 and average waiting time would be 2.8 and turnaround time would be 5.8. Okay. Now there are some advantages and drawbacks of this algorithm, and as well as we will also discuss the convoy effect. See what is the convoy effect in FCFS in the next video. So I'll see you in the next video. Till then, bye bye, take care.